Okay, we are going to tackle 4.6b today. It also has 4 pages, just like 4.6a had, but again, no need to panic. We'll be fine. So we are supposed to solve this equation, and it does not tell us how to solve this equation, but there is something that can be super helpful if you recognize that this side over here looks like a perfect square special case. So let's see if it is. This looks like a perfect square special case. Remember those perfect square special cases were f squared plus 2fl plus l squared factors to be f plus l squared, and the other one was f squared minus 2fl plus l squared equals f minus l squared. So to check and see if it's perfect squares, we look at this first term and we kind of unsquare it. 9x squared unsquared gives me 3x. We look at the last term and we unsquare that. 25 unsquared gives me 5. And then I multiply those together times 2. 2 times 3x times 5. And see if that gives me that middle term. 2 times 3x is 6x. 6x times 5 is 30x. So it is a perfect square special case, which means I can factor it into, remember this guy was f, this guy was l, so it's going to factor to be 3x plus 5 squared. And then it's still going to be equal to the 49 that was on the other side. Now, how does that help us be able to solve this? Well, I'll tell you how. Now we have something we can use the square root method with, because we have a square thing, a square term, and a number with no x term. In fact, this kind of resembles how it would end up if we were using completing the square. Anyway, we can use the square root method, which means we take the square root of both sides. On the left side we get 3x plus 5. On the right side we get, don't forget the plus or minus, so plus or minus 7. Now we have to do a little bit of work here to get to our answer. We'll need to subtract 5, which remember goes in front of that plus or minus 7. So now 3x equals negative 5 plus or minus 7. But we're not done. We still have to divide both sides by 3. So we'd get x equals negative 5 plus or minus 7 divided by 3. We need to finish that to get our two answers. So x would be negative 5 plus 7 divided by 3, or negative 5 minus 7 divided by 3. Negative 5 plus 7 is 2. 2 divided by 3 is 2/3. Negative 5 minus 7 is negative 12. Negative 12 divided by 3 is negative 4. So those would be our two answers. Now I realize that that was a little bit of work and may seem kind of extra, but if you tried to solve this equation by another method, such as factoring, it can't factor, so you'd be stuck there. If you didn't notice that it was a special case and you tried to use completing the square, let me show you what would happen. So what if you don't notice the special case and try to complete the square? I'll show you what would happen. So our first thing to do is that I would have to get the variable terms on one side and the numbers on the other, so I'd subtract the 25 over. So I have 9x squared plus 30x equals 24. Then the next thing I have to do is divide each term by the coefficient of the x squared, so divide each term by 9. So now I have x squared plus 30 over 9 simplifies to 10 thirds x, and 24 over 9 simplifies to 8 thirds. And then you realize the next step is to figure out the factoring number and the completing the square number. The factoring number, I do b divided by 2 or 1/2 times b. So I would have to do 1/2 times 10 thirds, which would be 10 sixths or 5 thirds. And then the completing the square number, I'd have to square that number, and I get 25 ninths. I mean, like, that's doable, but you're going to have to deal with a ton of fractions, and then it's going to be yucky. So my best advice to you is, if it looks suspicious like it might be a perfect square thing, go ahead and do it that way, because that is a lot easier than completing the square with those fractions and stuff. Okay, next example. We are going to find k so that this would be a perfect square. Okay, this is a little bit of thinking backwards. We've been knowing what like b is and then figuring out what number we would have to add to both sides, but this time it's different. So this problem, this right here is b. It's the number in front of the x term. And this right here, 121, is the number that completes the square. So we can figure this out because we know that the number that completes the square is actually b divided by 2 squared, because b divided by 2 is the number that we use to factor, but then b divided by 2 squared is the number that completes the square. So since our number k is b and 121 is the number that completes the square, we can write this equation that 121 equals, instead of b, we're going to use k divided by 2 squared. And now we can solve this equation by the square root method. So we would take the square root of both sides. And remember, when you do that square root, that's going to be plus or minus 11. And that's going to equal k divided by 2. And then multiply both sides by 2. So then we get that k equals plus or minus 22. And they've actually told us that it's x squared minus kx. So since there's already a negative in front of it, we don't really need to worry about the sign. We can just say that k is 22. One down, 3 to go. Okay, solve by completing the square. Now we get to do a completing the square problem that has a coefficient in front of the x squared and see how that plays out in terms of finishing an entire problem. So our first step in solving by completing the square is to get the variables on one side and the plain number on the other. So I will add the 1 over to both sides, and I get 2x squared minus 2x equals 1. Next step is going to be to divide both sides of the equation, or excuse me, all the terms, divide each term by a, which is the coefficient of x squared. That coefficient is a 2, so I'm going to divide by 2, divide by 2, divide by 2. So I get x squared minus x equals 1/2. The third step is to get the factoring number, which is b divided by 2, and the completing the square number, which is b divided by 2 squared. So my factoring number is going to be b divided by 2. Well, b is -1, so my factoring number is -1/2. My completing the square number, I do that number squared, which would be -1 times -1, which is 1, 2 times 2, which is 4. Now the 1/4 then is going to be the number that I will add to both sides. So I'm going to take my equation from here, x squared minus x equals 1/2, and I'm going to add 1/4 to both sides, because that's what I do with my completing the square number. I add it to both sides. My next step is to factor, and remember, that's the easy step. We do x and then the factor number squared. Okay, so my factoring number was -1/2. So when I factor, I'm just going to go x, drop that number in there, minus 1/2 squared, and it's going to equal, I'm going to go ahead and do 1/2 plus 3/4. So, excuse me, 1/2 plus 1/4. And to do that, I will need common denominator, so times 2 times 2. So I have 2/4 plus 1/4, which would be 3/4. So that's going to equal 3/4. And then the next thing I'm going to do is take the square root of both sides, remember to do the plus minus, and then get two answers. So I'll take the square root over here, and the square root of x minus 1/2 squared is just x minus 1/2. The square root of 3/4 is a little bit more challenging. It's going to be plus or minus square root of 3/4. Now when you see the square root of a fraction like that, I want you to think about it like it's the square root of 3 over the square root of 4. So that's going to help us simplify it. The square root of 3 doesn't simplify, so we just leave it plus or minus the square root of 3. But the square root of 4 simplifies to be 2. So now I have plus or minus the square root of 3 over 2. And I still have to solve for x and get my two answers. So I will add the 1/2 to both sides, so plus 1/2 to both sides. And remember that goes in front of the plus or minus. So I get x equals 1/2 plus or minus square root of 3 over 2. Now when you see answers that look like that, I want you to write them as a number plus or minus another number and then all over a common denominator. So what's handy about this guy is that they have the same denominator. So I can just rewrite this all over 2 as x equals 1 plus or minus square root of 3 and then all over 2. So 1 plus or minus square root of 3 all over 2. And so if you have to list these as two separate answers, it would just be 1 plus the square root of 3 over 2, comma, The other one would be 1 minus the square root of 3 all over 2. Now, if they ask you to find a decimal approximation, you would need to use your calculator for that. But I think for now, what we're looking for is these exact answers. Probably we should try another one that would have a coefficient, just so we get a little bit more practice before we move on to doing them on our own. So we'll do this one. Solve by completing the square. 3x squared plus 4x plus 4 equals 3. So keep in mind our first step is going to be the same, to move the variables to one side and the numbers to the other. So I'll subtract that 4 over, and I get 3x squared plus 4x plus 4, whoa, just kidding, 3x squared plus 4x equals -1. We can pretend that never happened. Then the next step is to divide each term by the coefficient of the x squared. So I'll need to divide by 3, and divide by 3. So I'll have x squared plus 4/3 x, leave a space so I have room to add something to both sides, and then that equals -1/3. So now we've got to figure out our factoring number and our completing the square number. So the factoring number, remember, was b divided by 2 or b divided by 2 or 1/2 times b. Now when your b is a fraction like this one is, 4/3, the easiest one to do is the 1/2 times b. So I will do 1/2 times 4/3, which would be 1 times 4 is 4, 2 times 3 is 6, and I need to simplify that to make it 2/3. So my factoring number is going to be 2/3. My completing the square number, what I do is I take my factoring number that I just got and I square it. So for completing the square, I'm going to take my 2/3 that I just got and square it, which means I'm taking 2 times 2, which is 4, and 3 times 3, which is 9. So my completing the square number is 4/9. That's the number that I'm going to add to both sides. So I will add 4/9 here and add 4/9 there. My next step is going to be to factor. That's the easy step. So when I factor, I just go x. I take my factoring number. Since it was positive, it will be plus 2/3 squared. And that's going to equal whatever I get when I add -1/3 plus 4/9. So -1/3 plus 4/9. I need a common denominator. So I'll have to do times 3 times 3. So that's -3/9 plus 4/9, which is going to give me 1/9. So on the right side, it's going to equal 1/9. Then my next step is to take the square root of both sides. So I will square root here, square root here. The square root of x plus 2/3 squared is just x plus 2/3. And then for the square root of 1/9, remember we're thinking of that like the square root of 1 over the square root of 9. Square root of 1 is 1, square root of 9 is 3. And don't forget, to use the plus or minus out in front of there. So x plus 2/3 equals plus or minus 1/3. And I still have to get my two answers, so I will subtract 2/3 from both sides. And remember that that's going to go in front of the plus or minus. So I have x equals negative 2/3 plus or minus 1/3. Now in that other problem, remember we saw that we had to write those as number plus or minus number over a common denominator. So we're going to do that. So x will equal, they already have a common denominator of 3, so we're going to have negative 2 plus or minus 1 over 3. Now since those two numbers can be combined, we will do these problems to get our two answers. So what's that look like? That means we're going to do negative 2 plus 1 divided by 3. Negative 2 plus 1 is negative 1, and negative 1 divided by 3 is negative 1/3. And then negative 2 minus 1 divided by 3. Negative 2 minus 1 is negative 3, divided by 3 is negative 1. So there's our two answers. Ooh, look what that did. That brought us to page 4. This is our last page here. And what we're going to do is we're going to use completing the square to change standard form to vertex form. Change from standard form to vertex form. All right, this again has like lots of steps, but it's okay because none of the steps are really hard, and we've just practiced doing a couple of these completing the square questions. Shoot, we should have changed this standard form to y equals ax squared plus bx plus c to y equals a times x minus h squared plus k. By the time you get these handouts, I may have already made that change. So if it's correct on your handout, don't worry about it. So the way that we're going to start is we are going to add or subtract the constant term to the side with the y. So here's my constant term, it's 5. I'm going to subtract it so that it's over onto the other side, and now it says y minus 5 equals 2x squared plus 5x. So I'm going to get the terms with the x's all together on one side and the rest of it on the left side. Then the next step is going to be to divide by the coefficient of x squared. And I wrote you a little note there that we're going to leave it like y plus a number over another number. So don't actually do any dividing on the left side. Just put over 2, over 2, over 2, like that. So it's going to be y minus 5 over 2 equals, go ahead and do that dividing, so x squared and 5 over 2 x. Then next we're going to add b times 1/2 squared to both sides. So first we'll find b times 1/2 squared. So in this case b was 5 over 2. So I'm going to take 5 over 2 times 1/2, which is going to be 5 over 4, and that's going to be my factoring number. And then I'm going to do 5 over 4 squared, which will be 25 over 16, and this is going to be what I add to both sides. Okay, so I literally just write plus 25/16 on this side and plus 25/16 on that side. and we're just going to leave that there for now. Our next step is going to be factoring. Remember, factoring is the easy part. That's going to happen on this side this time. So when I factor it, it's just going to be x, and then I use my factoring number, plus 5/4 squared. And I don't do anything on the left side. I just leave that the way that it was. So that's going to stay 25/16 plus y minus 5 over 2. Once I have it looking like that, where it's factored, I'm going to undo step 3, then undo step 2, then undo step 1. So step 3 was where I added b times 1/2 squared to both sides. So when I undo step 3, I'm going to subtract that number from both sides. Okay, so undo step 3. I will subtract the 25/16 from both sides. And that's going to leave me y minus 5 divided by 2 equals x plus 5/4 squared minus 25/16. Don't try and put that in with the parentheses, just tag it along the end. So it's not, you're not having to do any computations, you just kind of moved it to the other side. Then I'm going to undo step 2. Step 2 was to divide by the coefficient of x squared. Well, that was up here where I divided everything by 2. So to undo step 2, I'm going to multiply by the coefficient of x squared in the original problem. So I'm going to multiply by that number, and what I'm going to do there is I'm going to go times 2 here, I'm going to go times 2 out in front of here, and I'm going to go times 2 to this one. So what happens on the left side is that the 2 and the 2 cancel, so I get y minus 5 equals. This 2 is just going to stay put out in front, and this 2, I'm going to do 25/16 times 2, which would be 50/16, which simplifies to be 25/8. So that's going to be negative 25/8. And then to undo step 1 was to add or subtract the constant term. So to undo step 1, I will add or subtract the constant term with the y. So here I have minus 5, so I will plus 5 here, and I only need to add that to the constant term on this side. So I'll end up with y equals 2 times x plus 5/4 squared. And then this is really the only tough part. I have to do negative 25/8 plus 5. So you do have to do a little bit of fraction action, but it's not too bad. Let's go 25/8 plus 5 over 1. I need to have a common denominator, so that's going to be 8ths, which makes this times 8 times 8, 48ths, and then add those together. Excuse me, that was negative 25/8. Negative 25/8. So negative 25/8 plus 48ths gives me 15/8 positive, so plus 15/8. And now my equation is in vertex form. So I could, graph that, like not easily because it has fractions in it, but I could tell you how to graph it pretty easily. It has a vertical stretch of 2. It has a shift left of 5/4. and it has a shift up of 15/8. So the shift left and up tells me my vertex is going to be at -5/4, 15/8, and the vertical stretch of 2 tells me my pattern would be over 1. Remember, our normal pattern is over 1, up 1, over 2, up 4, over 3, up 9. But when I stretch by 2, I multiply all my ups by 2. So to graph this, I would start at the vertex of -5/4, 15/8, and then I would go over 1, up 2, over 2, up 8, and over 3, up 18.